Dr. Werner Gruber.
Ladies and gentlemen, I'm very happy that I can speak here about the science of cooking. And it has a good reason that I come from Austria to the UK. England is not known for famous special food. It's like Germany, and so I would like to give an introduction to the science of cooking. The real problem in science of cooking is we have two parts. We have one is the molecular gastronomy and culinary physics or physicists. The problem is that molecular gastronomy works with new substances to get new foams or texture. In culinary physics, we have to destroy preconcepts of cooking. Most people use recipes from their mothers or fathers sometimes, and in most cases these recipes are not the best possibility to create a good meal. So we will discuss this problem, and first of all we discuss the problems of vitamins. Many people would like to cook very healthy because they think that cooking healthy, yes, the life will be better, but that's wrong. Vitamins are not the real problem in our world. In our world, the problem is we eat too much. The second part, we don't sleep too much. That's a real problem. And we don't move. All three parts are mine, okay. But vitamins are not the real problem in our world. In Austria, many people think that they can prevent the flu, the influenza, by drinking a lemon tea. Lemon tea is hot water, lemon juice and sugar. Tastes okay, but it cannot prevent the influenza. If you have the influenza, you can drink the lemon tea, but personally I will take 2 shots of rum or whiskey, and then I will have no problems with the flu. I think so. And if you don't believe this, and you would like to take vitamin C, then I would prefer to eat some sausage, because in a sausage you have 10 times more vitamin C than in 1 lemon. So use sausages for prevention against flu, or rum and whiskey. So we have to ask, how can a scientist help in cooking? Cooking is something which is made 20,000 years in human being. Scientific thinking in the last 400 years. And yes, I'm sure that everybody of you has thought in the scientific way during cooking. The first is to create the hypothesis, how we can make it better. You have eaten something and it tastes or smells not very well. What do? You think about the problem and you will create a hypothesis how you can make it better. So this is the first start of a scientific career. The next part is to create an experiment. With an experiment you can test your hypothesis, you can do it better. You have only to cook after the recipe you have and only change 1 parameter. The problem is that the parameters depend on each other, so please don't change 2 or more parameters. My mother changes more than 3 parameters, the most time 4 or 5 parameters, and afterwards it's good, but it's not the original recipe. She cooks she cooks anything. This is the experiment, and after the experiment, you have to do the third part, a documentation. Only with documentation you are working in a scientific way. Let's think about a perfect turkey. Turkey at Christmas, what we have to do? We have to do 12 or up to 15 perfect turkeys. You have to make up to 12, 15 turkeys to get a real good turkey, the best one. And if I say the best one, I mean that in 20 or 30 years, the people will say, yes, this turkey from the year 2012, this was Christmas. This was a real good turkey. So you have to do many experiments. And if you have an experiment made, it's not easy that you and your family, the next 12 days, you cook turkey. You will get large problems with your family. I tried it. So you can only make one turkey per month. But after 1 month, you have the problem, which parameter have you changed? And this is the problem, and so you have to create a good documentation. My grandmother was not a scientist. She was a real good grandmother, and she cooked really good. And in her documentation were the cooking books. In some cooking books, some recipes were struck through, and yes, she wrote, tastes bad. I tried it, she was right. Some other recipes smells well, but, and then some changes. Today, we don't have to strike through. We have Post-its, and you can see the amount of Post-its if somebody's cooking or try to cook. Okay, the next problem is to talk about the science of cooking. Yes, what we can cook. Personally, I would really like to talk about the Viennese cooking, known as Tafelspitz. It's a special kind of beef which is boiled and smells really good. Or the Wiener Schnitzel, a cutlet in Viennese style, or a chocolate cake called Sachertorte. But the problem is you don't know this, really. And so I would like to explain some things about the breakfast, soft-boiled egg, and how to create a good cup of coffee, and some other points. But first of all, what are the requirements of cooking? Why do we cook? The first requirement is to make hard-fibered food eatable. Which is hard-fibered food? Celery, carrots, and yes, vegetables, potatoes, we have to cook. Many people think that we have another part that is soft rubber-like food. What is a soft rubber-like food? It is very easy. Meat. We boil meat that it gets softer, but that is not right. Here I have brought meat from Austria, and it is very soft. You don't have to boil it that it's got softer, or yeah, you have and here, this is a typical Vienna Schnitzel. This is hard. After not boiling, after baking. So we have the problem between soft and hard and mellow and tough. Normal meat is stringy or tough, and after cooking, after boiling, it is mellow. Cooking means up to 1 hour or more. only to boil meat for a few minutes or grill a meat for a few minutes, it will not get mellow. Okay, that's the first part. Now let's discuss the problem of a good cup of coffee. The coffee, we have many possibilities to create good, or to make good coffee. The espresso machine and the drip coffee machine. These are the two main possibilities. In the audience, who drinks coffee, please? Okay, yeah. And who prefers espresso? Okay. Okay, we're in the United Kingdom. Who prefers drip coffee machines? And the rest drinks the coffee made by which method? Mocha? Okay. In the whole of Europe, except the UK, typical, sorry. Most people prefer espresso cafe and they don't prefer drip coffee machines. There is one reason: drip coffee machines gave in the most cases, the coffee tastes not good, the coffee tastes not well, and there is not much caffeine inside the coffee. Why is this so? Professor Illy, known from Illy Coffee, made many experiments, and he found out that for the perfect coffee, you need 92 degrees Celsius. If you have this 92 degrees Celsius, you get a real good coffee, even by a drip coffee machine. So the problem is, if you don't have this 92 degrees, you get a really bad coffee. It's a coffee, we can say, yes, it's flat, stale, vapid, like in Germany. Germany's coffee is real bad, believe it. And so, yes, you need 92 degrees. So you have two possibilities to check this. The first possibility is you use a thermometer. That's easy. Everybody has this, so no problem. I give you a better solution. The solution is here, a drip coffee machine, and you see the pocket for the coffee. And now we don't make coffee, we use a biological sensor, an egg. This egg is medium-sized, has room temperature, and we put it inside without any filter. Yeah. Okay, then you need water. And yes, you will start. Okay, and then you have only to wait a few minutes if the water drips through the whole machine, and then yes, you got, if it's really exact 92 degrees, a perfect soft boiled egg. The white of the egg is hard, and the yellow stuff, or the yolk, is soft, really soft. If it's not a good machine, the egg is too hard or too soft. Okay, now we have to wait a few minutes, and now we can discuss another problem with coffee. It's the problem, a cappuccino without or with a milk foam. We tested this in many coffee shops in Austria, and in Austria this part is called the Verlängerter, or here cappuccino without milk foam. So, and what is the reason for the milk foam? Okay, it smells better, but there is a second reason. We measured the temperature without the milk foam, and we saw that after 20 minutes, yes, we reach a temperature of 30 degrees Celsius. Interesting, if we use milk foam, the temperature reaches 36 degrees. We have here a difference of 6 degrees. This means the coffee is hotter than without milk foam. But very interesting is this part of the curve. In this part of the curve, the milk foam is colder than the coffee. And so in this part, yes, it will cool down. And after the exacted 6 minutes, it is with or without milk foam is the same result. So if you would like to drink your coffee or cappuccino very fast, use milk foam because it will cool more down. And if you have time for your cappuccino, please use even milk foam because it is hotter than without them. So now we have to discuss how many minutes we have to boil a 3-minute egg. You can work with a drip coffee machine, or you can use this formula. This is a really nice formula, and it's very nice. Sometimes my students with me at breakfast, and I ask them, would you like a soft-boiled egg? Yeah, I like this. And so we can create the diameter, we measure the diameter of the egg, and so on. And yes, it's a very simple formula. The first part, 0.0016, is a constant for all kinds of eggs, really all kinds of eggs. It's the thermal diffusion, thermal capacity, and so on. D stands for the diameter of the egg between the two poles in millimeters. Sorry. The temperature of water, of the boiling water, it is about 90 degrees Celsius, and the start temperature of the egg. If the egg comes from the refrigerator, you have 4 or 5 degrees, and if the start temperature of the egg comes, if the egg comes from the room, you have room temperature about 20 degrees. And if you would like to have a perfect soft boiled egg, the white one is hard, the yellow stuff is soft, you have to use for the inside temperature 64 degrees Celsius. So this is a nice formula, but there is only one large problem. I published this formula in Austria and Germany, and I got many emails because many people didn't know what to do with the ln. Okay, I know we have really problems with the PISA test in mathematics. So many people asked what I have to do with the ln. That this is a logarithm is not really known, and many iPhones, yes, the calculators have no ln. So we found here a real nice solution, a special template. Sorry that this template is given in German language. Here I have such a template, and if we have a camera, I will explain how to use it. You have an egg, you put the egg inside the template, and then on the left and on the right side you can read it's the diameter between 40 and 42.5, and if you want it soft or hard, if it comes from the refrigerator, 4 degrees, and so you can see 4 minutes and 20 seconds. This would be the perfect time for cooking the egg. Very simple idea, and so you can use the template, or you can explain the logarithm. It's cool. 2 possibilities. If you have a soft-boiled egg, a real good soft-boiled egg, sorry. I forgot something. Do you put the soft-boiled egg into cold or hot water? So not the soft-boiled egg, the egg you want that is soft-boiled. Who puts the egg in cold water? Okay. And the rest, no, who puts it in hot water? Okay, and the rest only eats scrambled eggs. Okay. Please don't use cold water for your soft-boiled eggs. The problem is, I'm sure, you know your pot, you know the amount of your eggs, you have the same size, the same eggs with the same size, and so on. So you get a perfect soft-boiled egg. The problem is, somebody in the family dies, one egg, you need one egg less, yeah. Or somebody comes to the family, you need one egg more. And so you have the problem, this can change. The pot can be destroyed and many other parameters can change. You need a clear, defined reference point, and this point of reference is boiling water. Boiling water in the whole world, even in the United Kingdom, water boils at about 100 degrees Celsius. One problem is the Everest. If you're on the Mount Everest, water boils at 72, 76 degrees, and there you cannot make a good soft-boiled egg. It's a large problem. You're at the Everest, and you would like to celebrate this with a good breakfast, and you have the problem with the temperature. But with physics, you have two possibilities. You need a pressure cooker. Okay, somebody has to bring it to the Mount Everest. Therefore, Sherpas. And the second possibility, which is very easy, is to use not water for boiling the egg. You can use oil. Oil will boil without any problems on the Mount Everest, and then you can use the formula and you can make a perfect egg, soft-boiled egg, on the Mount Everest, if you're interested in. Okay, let's take a look to our soft-boiled egg. The drip coffee machine is ready. So it's hot. So, yeah, it's real hot. So let's take a look to our soft-boiled egg. If this is a good drip coffee machine. Okay, the first part, the white egg is okay. And now, come on. Yeah. I use this drip coffee machine if I have talks in Germany to make a good coffee. And yes. So just a minute. Yeah. Okay, this is the part. Yeah. At Himalaya. There's a special kind of salt, which is called in Austria Himalaya salt. Do you know this even here? You don't know Himalaya salt? Okay, well, perfect. Because in Austria and Germany, you can buy a special kind of salt, Himalaya salt. This salt is said comes from the Himalaya, but that's wrong. It comes from Pakistan and from Poland. And they say this salt is very, very healthy because you can see on the salt these red parts, and many people think that this is very, very healthy. But these red parts are only iron oxide. And if somebody would like to work with iron oxide, yes, take a rusty nail and cook it in the soup and so on. Okay, that's no, okay, you don't have Himalaya salt. Okay, another interesting part in the breakfast in Austria on some special days, it is used if we have hard work to do to eat a special sausage. You know this special sausage named as hot dog, but the hot dog, only the sausage, was invented in Austria, and the typical name therefore is Frankfurter. Perhaps you know it from the musical. And in Germany it's called Wiener because it comes from Vienna, but here we call it hot dog sausage. So we have many problems in boiling hot dog sausages. The first problem is that the hot dog sausage could burst if you boil it. We were the first who we measured the inside temperature and the pressure inside and cooking hot dog sausage during boiling, and it was not easy. And we found out that at a degree of 92 degrees Celsius, it's the same as the coffee machine, steam will be produced, and steam needs space. And so the sausage will rupture from one end to the other end. So that's the first problem. So don't boil hot dogs. Only boil them with a temperature of 80 degrees and you will have no problems. The second problem is large difficulty. If you boil a sausage, after 5 minutes, the sausage loses flavor. All the flavor goes by diffusion to the water. Flavor, salt, and fat, all the good things of a sausage, really, goes to the water. Okay, you can drink the water, but it's not the same. So we need a solution for this problem. And there are two possibilities. The first possibility is to use an oblation sausage. What's an oblation sausage? I'm not sure if it's called sacrificed sausage. You have to cut one sausage in many pieces. This sausage will be destroyed. And this sausage will be cooked. And if you cook these small pieces for a few minutes, you get a so-called saturated solution. In this saturated solution, you can put the other sausages, and then you will have no problems, and the other sausages don't lose in flavor. So it smells better. And yes, the problem is the saturated solution. It's very expensive, so I take the saturated solution to the refrigerator and use it 2 or 3 days later, second time. There is a second solution to make perfect sausages. And this is a solution you should really know what to do. Here I have sausage, and here I have 2 cables. And the sausage has 2 ends. So we have 2 electrodes. And now is the interesting part of the experiment. Power on. Don't touch the sausage. This is not good for revolution and pupils. Now you have to wait. If you see steam like this one, you have to stop. If you don't stop at this moment and work, and the current works for the next 30 seconds, the sausage will explode. Really explode. and that's not fine. Or you have a small dog, and that's like Christmas for him. So now the sausage is hot inside because the current works inside the sausage, not outside. Outside it's warm but not hot. Nice. No. Later, we have 3 Frankfurters hot dogs, if you are interested in. So, now you know how to boil a sausage. And now to the scrambled eggs. Who had scrambled eggs at breakfast today? Okay, we are not interested in the problem? Oh, yeah. I will explain it. The problem of scrambled eggs, you need time. For good scrambled eggs, you need, yes, several minutes. I show you the fastest scrambled eggs in the world. You need only this pan. Pan is cold. Then, okay, you need 1 or 2 eggs. We will use here 2 eggs because we have a large audience. This scrambled eggs is for all of you. You can be sure you don't eat so much. Okay, 2 eggs. And now you have 3 possibilities to make scrambled eggs. The first, you use heat. If you change the temperature, the scrambled eggs will be made. Everybody can do this, or most. The second possibility, you need acid. If you use acid, you should really know what to do. Or, to make it really cool, you use alcohol. And if I say alcohol, I don't mean the vodka with 43%. I mean alcohol. 95% alcohol for the breakfast. Ah. Okay. Normally, I take a spoon. Normally. Oh. So, you will see a very interesting here. I haven't done anything, and you will see that the alcohol coagulates the white egg. So, if you scramble now the egg, you will get perfect scrambled eggs without doing anything. Okay, scrambling, but that's all. It's ready. Okay. Unbelievable, I know. So, this for the breakfast is really good. It's no. The water you see here normally is, just a minute, I'll write it down, is normally boiling away. Sorry. And you put the water away, and now perfect made scrambled eggs. Now, cold scrambled eggs is not very believed, we must say. And so personally I would say, yes, make it hot. And we have so much alcohol inside. Not enough. Oh, yeah, it starts. And if you have here, if you wait 2 minutes, it's the scrambled eggs are hot. But personally, please don't drink and drive. Don't eat these scrambled eggs and drive. And yes, this is the same effect if you drink alcohol beer or wine, or vodka, or ethanol with 95%, in your body, the same chemical reaction will start. So you can see it. The question is, would you like it? But this, so, no. Oh. Don't panic. Oh. Good for the electrician. Okay. Ladies and gentlemen, here you can see the fastest scrambled eggs. So let's come to the last point. This is the turkey. It's not for breakfast, but you can use this formula. And personally, this formula, it is really nice. If you see the simplicity, and it's like the third law of Kepler, the third square, and oh, it's nice. M. M is the mass of the turkey. Copper is a constant for all, yes, so turkey and all meal, which is similar to turkey. Yeah. And T oven is the temperature of the oven. Please use 220 grad Celsius, and the center should have 75 degrees Celsius, and you will get the time in minutes. If you use this formula, the turkey is really perfect. Inside, it is very soft, and it is, yes, it's really well done, and yeah, really perfect. Not for the breakfast, think to Christmas. So, we can talk about many things about the science of cooking. I hope you have learned some interesting things about the cooking with a coffee machine, or to use alcohol in a creative way. Yes. Thank you for your audience.